Assalamualaikum. Today we're going to learn how to solve capacitance in parallel and series. So the book I'm going to take examples from is Basic Engineering Circuit Analysis. It's the 8th edition by J. Irwin and R. Mark Nelms. I don't know how to pronounce that name, but this is going to be the book I'll be taking examples from. So first I'm going to give you a quick concept. So this is capacitance in parallel and this is in series. So capacitance in parallel is same as the formula to solve the capacitance in parallel is same as for solving resistance in series. Here you can see resistance, and same goes for the resistance in series is like capacitance in parallel. So I don't know if you understand what I'm saying, but here you can, I'm sorry I did a lot of cutting because I just wrote the wrong formulas, but I corrected them. So the formula of solving resistance in parallel is this, and solving capacitance in series is same as solving resistance in parallel. Just that it's for resistance and this is for series, for capacitance. And solving resistance in series is like solving capacitance in parallel. It's a very easy it's a very easy thing to solve. So I was making this video and I wrote it while making it, and then I just understood that I wrote these formulas wrong, so I'm filming it again. So the page may look very dirty. So let's jump to the examples. So this is example number 1. This is actually A and this is terminal B. These are two here, capacitor A, capacitor B, and capacitor 3. I didn't want it to write CC, so I wrote C3. You can name them, give them any names, doesn't really matter, it's just for understanding. So first we're gonna solve these capacitors in parallel. So we're gonna solve these two in parallel just like we solve resistance in series. We're gonna add them, 8 plus 16, 24 microfarad. Then this is going to come in series with 10 microfarad, 24 microfarad, 10 microfarad. Then we're gonna use this formula, and look, this is the thing we have to understand. 10 goes here, 24 goes here, cross multiplication, and 24 plus 10 divides. But we don't want a reciprocal, actually we want the real values. So we can do this and take a reciprocal, reverse it. So the 240 comes up, 10 plus 24 goes down, and we get our answer. This was a very easy example. Solve these two in like you solve, just add them like you solve a resistance in series, and then this is going to come in parallel. Now we're gonna look at this example, which is a little bit difficult from the first one. I'm taking two scenarios when the switch is closed and when it is open. So first, when the switch is closed, these two are going to be in parallel, these two are going to be in parallel, and when we're going to solve it, these both are going to come in series with each other. So when the switch is closed, these two are going to be in parallel, these two are going to be in parallel. So for this side I've written CP1, C parallel 1, and for this side CP2, C parallel 2. You can write anything here, doesn't matter. So when we're gonna add these two, we will have 12 μF. When we're gonna add these two, we're gonna have 24 μF. in the end result, they both are going to come, CP1 CP2 are going to come in series with each other. For this we're going to use this formula, which is E total CP1 multiplied by CP2 CP1 plus CP2. So we're gonna get 8 mu farad, and then we're going to take the scenario in which switch is open. So when the switch is open, so when the switch is open, these two are going to be in series, and these two are going to be in series. We're going to solve these two like in the formula for capacitors in series, and we're going to solve these two like capacitor in series, and in the end these both will come in parallel to each other, and we're going to add them. So here you can see it's 8 mu farad, and same is here 8 mu farad. This is also 8 mu farad. It was kind of disordered, so I wrote it again. The answer should be same because like resistance, capacitors have their own value. Even if the switch is opened or closed, it doesn't matter. So thank you for watching this video. I hope you learned something from it. If you want more tutorials like this, and you can request me any video related to your engineering subjects. And this was my first video, so this may look kind of clumsy, but please ignore it and please support me. I actually don't have any subscribers or anything, so please do subscribe and share this video with your friends who are having problems in their circuit analysis.